G'day guys. One of the things I was thinking about doing was part two of my Eratosthenes tests. In part one, I've already, I already tried to estimate the sun height and the potential radius of the Earth. But in part two, I thought I need to breach the next step, and that will be to get some sort of rough estimation of where the moon might be, how far away it might be, according to what the globe model would say. And later on after this, when I get my head around it, I'm going to try to figure out if I can estimate how far away the sun is for part three. That's going to be a lot more trickier. This one I think will be a little bit more easier. I think getting the radius and the sun heights for the Earth was probably about as easy as could come. The moon's going to be a bit trickier. The bigger the distance, the more accuracy really can muck things up. So because like I'd shown on previous assessments, when it came to these angles here, they're whole numbers. Whole numbers can muck you up a little bit. If there was like 64.28 or something like that, you could really increase your accuracy. But because they're whole numbers, they leave me a full 1 degree of accuracy out, and so that could be the distance. That could be the difference of 100,000 kilometers or something like that. I just don't know, but I'm going to do it anyway. So what I've got here, I've got a blank Earth, which has got radius from pole to pole. I've got the diameter here is 12,713 kilometers pole to pole, and I've just got some generic things up here from another one that I did here, where I did South Sweden and South Africa and stuff like that. So I'm just going to use that as a block to be able to put things into. I've got some brand new locations which I've never done before, and so I'm going to introduce them to you right now. So this place here, Luderitz, never heard of it before, so it's coming to you fresh, from Namibia, which is, I believe, is on the 15 degree line. So as you can see here on Google Earth, 115. As you can see straight down there, where is it? Luderitz, right there. You see here, it's not too far off 15. And I was going to line it up with another place I recently discovered too, and that is Longyearbyen, which is in Svenberg. Okay, so this one is, here it is, yes. Longyearbyen from Svalbard, and the other one is from Namibia. Now the other locations I thought would go a little further around. I thought I'll bring back Australia. Let's northern up here. So I thought, let's try and find out what Perth is aligned with. So I got Perth in Western Australia, and I found that it aligns with Beijing in China. Certainly have not done any drawings from any of these. So as you can see here, Perth is somewhere near the 116 mark right here, and if you follow 116 straight up, you're pretty much, here's my little chart thing, here we go, 116 right here, that's that line. It pretty much lines up with Beijing. So what I'm going to do is I'm going to put it into fast speed like I've done in previous videos. I'm going to start entering them to both on two different types of globes, so that I've got one for one variation, one for the other variation, and I'll come back and I'll find out roughly what they say the moon distance is. And before I go on with that, sorry, I've picked the 7th of September this month, which is past, so it's already It's already happened already, and I picked it because it was the half moon, so it was the third quarter. And I picked that because it seemed to have the moon like above the surface. Some of the other ones, like today, some locations were below the surface. And I was like, well, can you trust that sort of stuff? You probably can, but what we ultimately want is, well, we want a moon that we can see in the sky. So I've tried to pick the 7th because in all the diagrams I've got, the moon is in the sky, and so it should be measurable. So go into fast mode, and I will put these 4 cities into the computer. Alright, back to normal speed. So, as you probably would have seen, I've just drawn all these things fresh, and like, I have to admit, I'm surprised. It's the accuracy on this has thrown some very, very big different results in there. So, as you can see by here, long by year, by yen, Norway, it's 78 degrees north and 22, well, 0.22. There's no minutes and seconds on that one. The moon seemed to be at its peak at 6:55 a.m. and at a 38 degree altitude on the south direction. So let it go back to here we go. Long by year. Okay, so when it was, what I'm trying to do is, I'm over here, I'm trying to get it to like 180 or 0, and as you can see, the altitude says 38 degrees, and through it says 6:55 or 6:56 a.m. And so that's what I'm trying to use. I'm trying to use the absolute peak where it's basically dead above the person's head. And same thing with this one over here. So as you can see, when it reached the peak and it hit 0 degrees north, altitude was 36 degrees, and it's 6:56. So that was pretty much the time. So yes, just to confirm it. So Luderitz is 26 degrees, 26.6 south, and Longyear by Yen is 78.22. So you can see 78.22, 38 degrees south, and Luderitz is 26 degrees 0.64 south and 36 altitude north. And you can see by these arrows here, we've got 36 degrees for the moon angle, 26.64 matches the coordinates, 78.22 right there, and 38 degrees south altitude. So this moon has come out roughly around here, or just done a just generic circle. It doesn't really mean anything. And this one's coming up with a distance of 512,596 kilometers, which, as far as I know, is far beyond where the moon is estimated supposed to be. Now, this other one here, I got Beijing, China, which is 39.9 degrees north, and the altitude for the moon was 76 degrees south. So where is Beijing? Okay, so Beijing is 39.9 degrees north. Let me just double check that. Yeah, 39.9. And the moon rise at there with 76. Let's see, 180 degrees. Yep, we're at 76 degrees in the southward direction. And in Perth, we have 31.9. You'll be able to see 31.9. And I got 31 degrees north altitude. So let's have a bit of a look at this is Perth, where it's at 360 degrees north, or 0 degrees north, 6 o'clock, 31 degrees altitude. So 31 degrees altitude, 6 a.m. You can confirm it by there, 31 degrees in the northward direction, 31.95, 31.95. 39.9 for the position of Beijing, and 76 degrees south. And this obviously this is 0. It goes up to 76, and that's 9 degrees up. So if it was going northward, it'd be going towards this pole instead of that pole. And as you can see here, this one's come up a bit shorter, 350,094 kilometers, which I think is under. Because if I go to double check what the moon is, just in your general research, I believe it's supposed to be, it averages 364,000. But I don't know if that's halfway in between, or whether or not it varies between 340 going out to 390 or something like that. I'm not too sure. Either way, this is fresh as you can come. I haven't researched these coordinates prior, and this is what I've come up with. So yeah, so one is slightly below what the target is supposed to be, and one is quite a good shot past. But as you can see, generally it is in that mid 100,000s range of distance. I did do a previous test just to see if I knew what I was doing correctly, and they were ranging at something like 320 to 370,000 kilometers. And so this one here is quite a bit different. We've got 350,000 and 512,000. So quite a big distance in difference. But the one thing I've got to emphasize when it comes to this sort of accuracy is, because I'm using these whole numbers, if any of these angles were like 0.1 out, then it would just collapse the distance by tens of thousands of kilometers. So that's one thing I've got to emphasize. And yeah, there's no way I can excuse myself out of it. If I had the actual moon altitude, if it was 36.12, then the accuracy of this distance here would be far better. So if there was some sort of website which actually provides the accuracy, a few decimal places, I could be nailing this every single time. But with this poor accuracy, this is what I got. But I mean, this is a pretty damn good result, I still feel, even though looks like it's about 20% out of whack. But in terms of them saying that it's 364,000 kilometers, and my estimations are somewhere between that range, quite literally. I mean, their estimation is roughly around about here. I think that that these drawings are telling a somewhat similar story. So I think that's pretty darn good. All right, that's it for part 2. I may re-explore part 1 again, because I do want to test out more cities. I want to continue to, the more of these I get, the more experiments I get to test, the better I'll be able to continue to, get my averages. If I continue to get averages which are lower and higher, I'll be able to, at one point in time, I'm sure I'll be able to enter all of the numbers. If I go and get like 6 results, and then I put those 6 together and then divide more by 6, I might come to a very close estimate. And so, by me doing multiple experiments, I think I'll be able to actually improve my estimations and sort of find an alternate way around from this very very simplified accuracy. That's what I'll leave for tonight. I think it's a pretty good result. It's not as accurate as I want, but it's a result nonetheless. So it's not bad. I'll leave it at that. Good night.